Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. If you work with data or want to learn more about how the projects you've heard about on the show get used in the real world, then join me at the Open Data Science Conference happening in Boston from May 1st through the 4th. It has become one of the largest events for data scientists, data engineers, and data-driven businesses to get together and learn how to be more effective. To save 60% off your tickets, go to podcastinit.com/ODSC-East-2018 and register. Your host as usual is Tobias Macey, and today I'm interviewing Joe Alcorn about using Laboratory as a safety net for your refactoring. So Joe, could you start by introducing yourself?
Yeah, hi. I'm Joe, and I work as a software engineer at a company called Marvel. We're based in London, and I've been writing Python in some form for about 5 or 6 years.
And do you remember how you first got introduced to Python?
Yeah. So about 5 or 6 years ago, I got involved with a bunch of people that were running a Minecraft server, basically. And they would do lots of development here and there for the game and for the server. And a lot of that was based in Java, but they also did a lot of Python as well. And so from hanging around with them, I basically heard about Python and kind of got involved in a little bit of Python and a little bit of programming in general, actually. And that was how I first got into programming. And Python was my first language. So that was all down to that Minecraft server.
And as I mentioned at the introduction, one of the projects that you've been working on is something called Laboratory. So I'm wondering if you can just describe what the project is and what it does and what motivated you to start it in the first place.
So essentially, Laboratory is a library that is trying to help you gain confidence when you're refactoring. The way it does this is basically by taking the old code. So you've got some existing code, right? We call this your control block. And then you want to refactor it in some way, but you want to make sure it works exactly as it does before. It returns the same thing. It doesn't run too slowly, or it doesn't break in subtle ways. So you take that block and then you write some new code. And then to really make sure that everything works in production, when you've had bugs, and the bugs have led to bugs in your database, basically, because all the data's a bit broken. And then you don't know how the new code is going to react to, if the new code is really going to account for all those corner cases, all those edge cases, and those subtle little bugs that can pop up. So what Laboratory does is essentially runs the old code, runs the new code, compares them, makes sure the new code can't blow up the main execution. You don't want to let any exceptions slip out that way. And then you can basically be certain that your new code works as it should. And what motivated me to start the project was that I read a blog post about GitHub and how they use this technique to refactor some of their complex permissions code. And so at the time, we were doing something similar at work, and this was something that could obviously be very useful. The only problem was the library they built was in Ruby, and we used Python. So that was the motivation.
And given that you had this existing project to use as inspiration, I'm wondering how much of that you looked at to inspire the implementation of laboratory and how much of it you had to figure out yourself due to the differences in the target languages and their sort of idiomatic paradigms?
So yeah, originally I tried to keep the implementation quite close, and that was mostly because I wanted to get up and running quickly. But it led to an API that was not super nice or super idiomatic, I think. So about the start of this year, I decided to rework it a little bit. It's just less clever now, which is normally a good thing for APIs.
And when you were doing that refactoring of the laboratory code, did you happen to use laboratory itself to ensure that the operation was staying consistent?
No, sadly not. Because I was making breaking changes anyway, right? Yeah, I don't know. Actually, in fact, if I'm thinking about it, using laboratory for a library would probably not work super well. But if you're, say, running a service, you know, where you have control over, you can gather all the results and whatnot, that's when it would really be handy.
And what have been some of the most challenging aspects of building and maintaining the project?
So one thing that I realized recently is that the docs just weren't very good. Like there were some undocumented features, and it was just kind of hard to. There was no proper quick start guide. There was no easy way to get up and running super quickly. So I think that's always an issue, because a lot of the times I just want to kind of build something and throw it out there. But if you actually want people to use it, or if you want to be able to use it yourself in 6 months when you've forgotten how to use it, you need documentation. So that's been one of the things. But in terms of maintenance and building, I wouldn't say it's been too much trouble. Because like I originally pushed it out over like a weekend with the original API that I was talking about, and then maintenance has not been very much since then, because it hasn't changed a lot until this more recent API change.
Yeah, it definitely seems like the kind of project that has the potential for being essentially done after a certain point, because it's a fairly limited scope of operation. So once you get it to be usable and consistent, then you don't necessarily need to keep iterating on it and adding additional features, because that might add to the overhead of the runtime and create adverse impacts on the production system that you're using it for, because of adding too many bells and whistles to it, where you really want to make sure that it's just doing one thing and doing it well.
Yeah, precisely. I think that's definitely a good philosophy to follow.
And for somebody who's interested in using Laboratory in one of their existing projects to do a substantial refactor, I'm wondering if you can just talk us through the workflow of getting Laboratory set up and setting up different experiments, and what are some of the pitfalls that users should watch out for while they're doing that implementation.
So essentially, to get up and running, you would obviously need to install the library, which you can do from pip, and then all you need to do is make an instance of a class, and you tell it, this is my control block, this is the good code that I know works, and you say, this is my new code that might work, but we'll see. And then you can call a method to start the experiment, and that's really the simplest way. But the hard part is obviously getting your new code to work right. So, I mean, Laboratory really tries to stay out of the way. And like you said, it's very limited in scope. There's not so many bells and whistles. So there are a few pitfalls or caveats. So because you're going to do more work, you're going to run the old code and the new code. Obviously, it's going to take longer. And if that really matters for your application, then you should find another way, or you should only run your experiment 10% of the time, for example, or 1% of the time, or, whichever makes sense. So there's that. But also, in a web application, for example, if you are running an experiment and your experiment is writing data in your control block, obviously your candidate is going to have to do that too. And that means there's going to be, multiple writes or changes in the cache or something. If your candidate affects any state like that or has any side effects, then that could impact your control block, which means your real users are seeing real failures. So you do have to be careful, and you have to be mindful when you are designing an experiment. Generally, if you're just fetching stuff from a database, for example, or just reading state, it'll be fine if you can take the performance hit, of course.
And so a couple of questions I have from there is, one being, when you mentioned the overhead of running both code blocks at the same time, I'm wondering if you have looked at doing anything to parallelize the different experiments so that you can potentially spread them out across multiple threads or multiple cores to reduce the impact of that runtime overhead?
Yeah, so it's not something I've actually looked into, but part of the reasoning behind changing the API at the start of the year was so that this would be possible. Because essentially, in the old API, you would have to use a context processor and then call your function yourself. But in the new one, Laboratory actually does that for you. So you tell it your function, you tell it your arguments, and then Laboratory takes care of running them. And that means that we should be able to just the experiment to run them in like a multi-threaded way or a multi-process way, or however you'd like to do it. I was thinking of looking into it and adding a contrib module or something to use async IO in Python 3 or something, but it's not something I've actually looked into much yet, and I've not done much parallel Python programming before either.
And the other thing you mentioned is that by performing I/O operations or creating side effects in the code block that you're trying to refactor, it can complicate the ability of Laboratory to run these experiments because the different pieces of code might stomp on each other and dirty the overall state of the system. So I'm wondering if you have found any useful strategies to allow for either stubbing out the external interactions while still executing the rest of the logic flow so that the experiment can run through most of the process and then maybe just rely on the existing data, or even having multiple sort of output systems, either running two databases in parallel and having different configuration options for the experiments or anything like that?
Yeah, so, it's not something I've put much thought into because I've just tried to avoid it, really. I think it would depend a lot on the specific application, perhaps. I think it's hard to give a good answer anyway.
Something like that, it's definitely very difficult to speak to in any sort of broad sense because everybody's system is very context dependent, and so trying to provide a universal approach is ultimately going to fall flat for somebody. So it's best to sort of leave that up to the implementation of each person in their own project. And one of the necessary bits to ensure that you're getting value out of Laboratory is being able to retrieve the results of the different experiments so that you can compare the control against the experiment. So I'm wondering if you can talk a bit about the way that Laboratory allows for retrieving that information and some workflows that you've used for performing those comparisons to ensure that the candidate code is doing what you want it to.
Yeah. So essentially, when you've run both your bits of code and you have seen if they match or not, you can publish this data. And by publishing it, you can obviously try and narrow or hone in on what's causing the mismatches. So the laboratory doesn't do this for you because, again, this is one of those things that is really going to be so different on each individual system or in each different deployment, you know. But what I normally do is I send a count of how many things have matched and how many things have not matched to Graphite, and then make some graphs out of that. Then you can see exactly how many times it's going wrong and how many times it's working. And then you can also take the actual return values of the functions you defined, so your control and your candidate, and then you can maybe pickle them or something, put them into Redis or write them to disk or wherever you like, and then you can come in later and inspect them and see why they don't match, or how they don't match, should I say, and you can see any context you've set around them. And then that way you can use that data you've got to go and make changes to your codes. And then when you push those out and deploy those, you'll hopefully see the effect in your graphs. And then it's just a case of iterating then, because what you've basically done is establish a feedback loop, and that will ideally help you figure out how to completely fix it. Or maybe you'll figure out that there are too many edge cases and you need to rethink an approach entirely or something like that.
And you mentioned at the beginning that library code might not necessarily be a good candidate for the type of project that you would use laboratory on. So I'm wondering if you can just provide some examples of some of the types of code that you use laboratory on for doing these complicated refactorings, and if there have been any cases where you wanted to be able to use laboratory, but because of the structure of the code or the nature of the system, it wasn't really a good fit.
Yeah, so one example of a time I've used it, we were upgrading, or updating rather, how team members authenticate against some projects that belonged to their team. And we had the old method, which we trusted to work, but there was quite a lot of logic, and there were lots of different branches, and it was kind of hard to follow. So we couldn't, it's hard to be sure that our new code actually matched up. And that's kind of a perfect fit, because you don't know, or you don't have much confidence in your new code because you can't. And also, it's not something that you want to get wrong, because if you do, other people might be able to access data they shouldn't. So that was really a perfect fit for the library.
And so given the fact that laboratory is intended to be run in production and provide a certain measure of safety for conducting these experiments, I'm wondering if there are any particular methods that you've used to ensure that users of the library aren't going to suffer from a drastic increase in either operational overhead or unintended aberrations in the functionality of their software, or sort of unexpected exceptions that might cause some sort of termination of a existing routine.
Yeah, so the main way I've tried to do that is by basically keeping it as small as possible. It doesn't do a whole lot, but it is quite powerful in that. So there's obviously just not doing much. It means there's less surface area for bugs, obviously. But then also development processes. I've used lots of tests and things like that. But in terms of like the actual code at runtime, it really just catches any exceptions that your control blocks raise. Sorry, not your control blocks. It catches any exceptions your candidate blocks raise, and that way they can't interrupt your good code. Now, it doesn't stop the control blocks from raising exceptions, because that is the expected behavior, or that is the correct behavior, whether that is actually a bug or not.
And are there any new features or improvements that you have planned for future releases of Laboratory?
The main thing would be to fix the documentation, or not fix, but fix it up a little bit, because at the minute it's kind of split between the README and read the docs. So I would like to move that over and make sure everything is documented. Other than that, I would like to look into what we were talking about earlier, running them in parallel, the old and the new code. So I think that would be fun to look into. But other than that, I really think it's best to keep it simple. Oh, actually, so at one point I was working on a little helper library to help you store the results in Redis or send them to your stats or metrics collection. But I kind of paused on that. But I think it'd be interesting to pick up again if there's some free time.
Yeah, I think having some sort of a plugin interface, like you mentioned earlier, for being able to have a way to create these contrib modules for sending to different metrics backends or logging out to different systems might be a useful addition to the laboratory project, where you don't necessarily need to ship it in the core runtime that you currently have, but it would still provide a broader set of functionality that people might be able to leverage or contribute to.
Yeah, because I mean, right now, if you don't have somewhere that you can send these metrics already, then it's a lot of work to get started. But with something simple that could, I don't know, so maybe I was thinking something that will collect them for you in a very simple way, as well as ones that would send out to like your established metrics collection service, just to make it really easy to get up and running. But
Well, for anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And so then I'll move us into the picks. And for this week, I'm going to choose the Chronicles of Narnia, the book series I've just started reading recently with my kids. And it's a lot of fun to revisit that. And we also watched the movies that they made a little while ago of 3 of those books. So for anybody who enjoys short, interesting fantasy read, it's definitely a lot of fun. So with that, I'll pass it to you, Joe. Do you have any picks this week?
Yeah, actually, I'm reading a really interesting book at the minute called Why We Sleep, and it's all about, well, it's pretty terrifying if you don't sleep enough. It's all about how important sleep is and the effect that sleep deprivation can have on your mind and your body. It's quite interesting.
All right. Well, I really appreciate you taking the time to join me today. Laboratory is definitely an interesting project and one that I'm sure I'll be able to take advantage of in the future, and one that I occasionally wish I had known about in the past. So thank you again for taking the time and for joining me today, and I hope you enjoy the rest of your day.
Yeah, you too. Thank you. Thanks for having me.